Hi, I'm here to talk about this program that I made in SuperCollider, which is designed to generate music in a certain way. Due to the complexity of the program, I wanted to make this video to explain how to use it and show off a bit of what it can do. I want to preface all this by saying that I'm not a programmer per se. The code is pretty messy and not very user-friendly. I know that someone who's better at this could accomplish the same thing in less code and code that's more optimized and easier to read. I had the idea for the program a couple of years ago and ended up learning SuperCollider specifically to try to see how much of this I could implement with some success, I think. I know with tutorials people like to jump right into things and not talk too much at the beginning, but there are some things I really feel like I have to qualify, so please bear with me. I'll provide a timestamp in the description for people who want to skip to the part where I actually talk about the program, but I do encourage you to hear me out at the beginning because I think some of what I have to say in the introduction is important. The program is inspired by my study of the Schillinger system of musical composition. You can definitely use it without studying the system, but those who have familiarity with the system will definitely have an advantage in understanding some of the processes and understanding how powerful they are in generating variety in music. This is a little bit different from other music creation tools that you'll encounter. It's definitely not intended to be a performance tool. It's more of a compositional tool. It's not like Max or PD where you generally have programs that have controls that you can manipulate or values that you can input in real time and have the program respond dynamically as you change the input. With this, you input values at the start and then you run the program, and it generates music based on those values. The program makes no sound by itself. With a lot of SuperCollider programs, you are dealing with synthesis and programs that generate sound. This is really designed to manipulate data that is then output in the form of MIDI. You'll need to have some sort of host application or some other way of receiving MIDI, and the sound will be entirely up to you, the instruments you have set up in your DAW or wherever you're receiving the MIDI. On a Mac, you'll probably be using the IAC driver to get MIDI from SuperCollider into wherever it's going. I'm not going to show you how to set all this up. The tutorial is already going to be pretty long as it is, and I want to maximize the amount of time I'm talking specifically about that and not dealing with setup issues. There's plenty of good tutorials out there about how to set up SuperCollider and the IAC driver, so you don't really need me for that. So as far as the program itself, what it's really for, the emphasis here is that it's a generative music program, but it doesn't deal with randomness in any way. A lot of generative music tools, I feel like the majority of them, deal with random generation. My goal here is specifically to avoid randomness. The idea is that variety and unpredictability are generated through the interaction of different sequences that each control the unique musical parameters. For instance, if you have a repeating sequence of musical notes and you have a different sequence of note durations, if those sequences have different periodicity, the result is an interference that produces variety in the original sequence. So for instance, if you have a sequence of 3 pitches and a rhythm composed of 4 rhythmic durations, like for instance a quarter note, eighth note, 16th note, and you superimpose those pitches onto that rhythm, it takes 12 units before the pattern repeats. Even with 2 interfering elements in that way, the variety can be significant. But with more interference you introduce, the more variety the more varied the material becomes. With simpler relationships, you could somewhat easily calculate how long it will take before the material will repeat, or you can calculate what that material would be. But it doesn't take many interfering sequences before the variety becomes difficult to directly calculate. So in most cases, there will be a repeat of the pattern at some point, but it might, depending on the complexity of what you're dealing with, it might take so long for it to repeat that you won't be around to hear the repeat. So just to be clear, the program is not random. It does generate calculated music based on your input. If you were to input values, run the program, stop it, and then run the program again without changing any of those values, it will create the exact same piece of music that you just heard from the beginning. Most, if not all, the features in this program are aimed at implementing processes described in the Schillinger system of music composition. Most are explicitly described in the system. Some are kind of indirectly alluded to, or I arrived at by implication. However, even in its existing complexity, the program doesn't even come close to emulating all the processes of that system. Some I didn't really know how to elegantly accomplish using code, again, being not a programmer. And many I just realized were outside the scope of such a program and what it could or should offer. The more I worked on the program, the more I realized that it was growing beyond my ability to easily maintain unity of function. There are over 50 different variables and parameters that can be set, and just understanding the effect each of them has on how the program as a whole works is often not straightforward, and at this point it was getting a little difficult to manage. So I didn't really want to add more. Or couldn't, in some cases, add more. There are a lot of more features that I would want to add, and some features that I have added don't behave exactly as I wish they would behave. But in some cases, I couldn't easily find a solution to fix those in ways that didn't break functionality of another existing feature. My goal here was to at least get something that was useful to me and expedite the generation of processes that are tedious to calculate by hand. In other words, calculating all the result of all these different sources of interference. Beyond that, I think it's a proof of concept that I admit I hope someone who is more capable than I am finds interesting enough to continue and build upon. My ultimate vision for this is to have a self-contained but sort of modular and user-friendly environment complete with a GUI that will emulate as many as possible of the processes described in the Schillinger system of musical composition. If anyone's interested in working on such a project, I encourage you to contact me. Anyway, let's get into the program.